Okay, welcome. This is page 61. It says exponents lesson 1, but this is actually lesson 8. Okay, this is our lesson 8 for unit 1 still. Unit 1 has 2 parts. So the first part is all about the types of numbers, greatest common factors, least common multiples, factor trees, prime factorization, and the start of radicals. What are radicals? How do we convert them back and forth for square roots and cube roots? So now we're going to be talking about exponents, and exponents are related to radicals, and you're going to find out how. So it says we previewed powers with whole number exponents last year. So it says now we're going to extend these into variable exponents and also integral. Integral just means integers, positive and negative, and rational. So that means we're going to have fraction exponents, decimal exponents. We could even have root signs. So now we're going to just review what the exponents are. Okay, so an exponent is basically a power. So I want to take a look at these powers right down here first. So for a power, you've got a base and you've got a little baby exponent. The exponent will always be on the top right-hand side. It'll never be on the left. You will sometimes get a base that is a digit. If I said 5 squared, that is going to be 5 times 5. We discussed that with powers. So the little 2 tells me how many of the bases you have. So this guy would be 5 times 5, and that would be repeated multiplication or expanded form. The whole thing is called the power. So this whole thing here is called the power. Your base is the large number. Your exponent is the baby number. Now I could have W exponent letter L, and that happens. You can have variable exponents and you can have variable bases. So they're showing us above, we have 2 cubed. They're showing repeated multiplication here. That is also called expanded form. Expanded form. Then we've got exponential form. We write it smaller. Now, there's something we need to know about digit 2 as an exponent and digit 3 as an exponent. Digit 2 means it's a 2-dimensional object or a 2-dimensional idea. Yeah. So 2-dimensional meaning there was 2 digits, 2 identical digits multiplying to give the answer. Where if it's cubed, you're going to have 3 identical digits. 2, 2, 2. That little 3 means you've got 3 identical digits. So exponent 3 also indicates that it's a 3D object possible. So are we talking about an actual cube here? And in this case, yeah, we could be. So where is the base? Well, the base is your base row of the cube. So my base here is going to be right there, the length of 2. That's where they got the base number of the 2. Now, if I drew a grid, and I drew a grid like this, and I divided it into 3 sections, I would measure my base, my lowest row, and that is a base of 3. So I'd have a base of 3. It's a 2-dimensional object, so it would be 3 squared. Okay, so that's the difference between a 2-dimensional versus a 3-dimensional object. Now, we can also have variables indicate the side lengths. So they're showing us here, instead of a digit, we could have a variable, something we don't know that's unidentified. Now, we're going to be working backwards so we can identify them. So, taking a look, all of these on the bottom here are different bases, and they're showing us what the base and exponent is. So we're going to identify them. Our base is the 4. The exponent is the 5. So the exponent's on the top right always. If you've got highlighters, it's nice to highlight. So you can highlight your bases, and then you can leave your exponents unhighlighted or circled, whichever you prefer. So on B, my base is a -3. That means there's 6 -3s. Now, when we talk about negatives in brackets, there's a couple things about negatives and negatives that are floaters. So we're going to identify that coming up on the next page. The exponent here would be the number 6. On letter C, our base is the letter X, and the exponent is the letter Y. So we can have bases and exponents that are both variables. That's fine. Turn your page. Whoa, not increase it. Okay, let's unzoom that sucker. Come on. Let's go into here. Let's see if it'll fix. There we go. Okay, page 62. Now it says a number that multiplies a variable is called the coefficient. So something that's sitting in front of your variable, the 7, he's sitting in front, he's your coefficient. Okay, so anything in front of a variable, we call that your coefficient. So if we want to identify coefficients, again, you could highlight them. Here I would have an 8. Here I've got a -3. And on the next one, don't forget, you've got a hiding 1 in front of any variable if you don't see it. So this guy's coefficient is actually a fraction. It's 1/7. That's the coefficient. So whenever you've got a fraction and the variable's on top, the bottom number is part of the coefficient. Okay? So for example, if I've got, let's say 3w cubed over 5. Your coefficient here is going to be the 3/5. That's your coefficient. Okay? So it will take the bottom number off and it'll be as a fraction. Now, when we take a look at how do we expand that then? Well, the digit itself stays a digit. So we notice if we are expanding this one here, the digit 7p, it's telling me I've got 3 of them. So that means I've got 3 7s and I've got 3 p's. So we write 7 times 7 times 7, but you're going to write it in the beginning. You're going to keep your digits together and your variables together. Is it wrong to write it like this or like this? No. You can totally do that if you want and then just count how many you've got of each. That's totally fine. But the preferred way is to keep the digits together and the variables together. Okay? So the preferred way is this one right here. And then if you've got a digit, you need to solve it. That's called fully simplifying or evaluating. So here I need to solve the digit part. And that's going to become my 343. So whenever you've got digits, you need to solve them if possible. All right, now we're going to write the next group as repeated multiplication. So we're going to expand them. If we need to know what is being multiplied, we need to expand. So how many 3's do I have in letter A? How many 3's?
1.
Just 1. How many A's? 4 of them. And how many B's? Just 1. Good. Okay, so you've got 4 A's, 1 B, and then you've got your digit out front. All right, how is C different? How is letter C different? We're going to go straight across. How is C different?
Because if something is in a brackets, that means each of them, like that 4 affects both the A and the B.
You're exactly right. So our 3 stays 3. The 4 is not attached to the 3. So the 3 is by itself. There's only one of them. But as Keegan said, the A and B, there are 4 of them. That 4 is attached to both of them. So I would have AB, 4 times, AB, AB. Or if you wanted to write it up here, you could go 4 A's and then 4 B's. Okay, both ways are correct. So whichever way you prefer, that's how you would expand it. How is letter B different then? Look at letter B going down. Which part, which digit, which letter, which variable is the 4 applied to? Is it all 3?
No, just the B.
Just the B in this case. There are no brackets. So my 3 stays a 3. The A stays an A. It's got a hidden 1 on them. If you can't see an exponent, it's always a hidden 1. That number 1 likes to hide. Then we've got 4 B's. So now I'm going to write my B's. And if they're letters, you're always going to put them alphabetical. The question itself might not. It might go W, B, L, Q, whatever. It might have a whole bunch of them. You're going to re-put them in alphabetically properly. Just so you know. So when you write your letters, variables are written alphabetically. All right. How is letter D different now? Now we've got brackets. Ryan?
What was it? The 4 applies to everything inside.
That's right. The 4 applies to everything inside. So now we're going to have 4 3's, 4 A's, and 4 B's. So I'm going to write them exactly like that. 4 3's, Then I'm going to have 4 A's, and they're all timesing. I'm using that little dot between. It's not a decimal, it's a times sign. And I'm using that on purpose because now we're dealing with variables. And if I put the letter X in there, it's going to look like a variable. So we're going to use those little fat dots in between to indicate multiplying. Whoops, B, not H. All right. Now we're going to talk about powers. If we want to evaluate them, evaluating is another way of saying solve it as low as it goes. Solve or simplify. All of those things mean the exact same thing. Reduce it as low as it goes. That includes the digit. So if there's an exponent on your digit, you're going to solve that exponent. So 10 exponent 3, both are digits, which means I can solve it to a digit. So I've got 10 times 10 times 10. Whenever it's a power of 10, the exponent tells you how many zeros you've got. So you've always got the number 1, and then it'll be followed by a range of zeros, depending on what your exponent is. So if I've got 10 to the 5, I'm going to have a 1 with 5 zeros, which means I'll have 5 different 10s. Okay, so I'll have 10 times 10, 5 times. Okay. All right, looking at the next one, 3 exponent 4. We want to evaluate that. So we have to remember how to put it in our calculators. So in our calculator, grab your calculator. We're going to use our exponent button now. So now on our calculators, our exponent button is the one under the clear button. It's that one that looks like the upside down V. I call it a teepee. So we're going to use our teepee a lot. So now we're going to type in the question 3 exponent 4. So I'm going to type in my 3 first, then my exponent, and you're going to see it's going to raise a box. Now, some of the calculators don't show a raised box. Some of them show the actual upside down V or teepee. Okay, so it depends on what your calculator does. Then you're going to hit the 4 and enter.
For some calculators as well, if it's just the TP for you guys, you also have to include a bracket as well.
Yes, in many, especially if it's a fraction. Fractions always include brackets. All right, back to where we were at. Whoops, not that one. Where were we at? Right over here. Okay, so 3 to the 4th is 81. Now we're going to check the difference between these negatives. So what are you noticing the difference as it's written out in expanded form? In the first one, we've got negatives in the brackets. On the second one, I don't have negatives inside the brackets. What's going on with the second example?
It's for the one on the bottom.
Yeah.
It's only affecting just one part. Well,
It is. So what number likes to hide in math?
1.
A 1. Good. So that's actually a -1 times 6 times 6. These 6's do not need to be in a bracket. They're just showing that it's separated from that negative sign. So now you could also write that by combining the first two and going -6 times 6. So if you see it written this way, you know that it is not a negative base. A negative base will include it in brackets. So this is not a negative base. This is showing you it was a floater. So floaters are -1s that are not included in brackets. Okay? So this guy is called a floater negative. Okay? And then this one is called a negative base. And again, it's a negative base because inside the brackets, the negative sign's in there, and the only exponent on your digit is a hidden 1. If you've got any other number on that digit as an exponent, it's not a negative base. For example, I could have -5 in brackets, but then I could put a 2 on it. So if I do this, 2 and bracket outside versus -5 to the 2, this is a floater, the guy on the left. It needs to have a hidden +1 on the inside to be a negative base. So the -5 here, that's the floater, that's just combining the -1 and the 5. So that's a -5 times 5. This one here will be a -5 times -5 because it's got a hidden 1 on the inside of your bracket. So if you've got a negative, you need a hidden 1 on your digit or a variable. Doesn't matter if it's a digit or variable. You need to understand that it's going to be a negative base if the exponent's a hidden 1. Okay? If it's any other exponent, it's not a negative base. It's a floater. So this guy is going to give us a negative 25 answer, whereas this guy is going to be 2 negatives, which will give us a positive 25 answer. So that's the difference. A floater will tend to give you negative answers, depending on what it's multiplied by. For example, you could get a floater times a floater, and a negative times a negative will always give you a positive. So it depends on how many floaters you've got. All right, so this first one will give us a positive 36. Whoopsie, that's not a 36. It'll give us a positive 36, and just like the one below, this one will give us a negative 36 because of the floater. Okay, because of the negative 1 being multiplied in. So that guy's a floater. That's the difference. Now we're going to take a look at the zero exponent. So these are a review of all of our exponent laws. Our zero exponent, anybody remember what that does from last year? It makes everything disappears and it becomes the digit 1. So, and it's because of this process. It's because of this pattern. So this is the pattern on purpose. And you can use any base number. It doesn't matter what base you are. But if you take your answer and you divide by the base number. So if I take this guy and I divide by 10, this guy divide by 10, this guy divide by 10, and then what do I get when I take 10 divide by 10? 1. And that's exactly why. Because every time you go down, you're dividing by the base. And as you divide by the base, you're going to get down to exponent 0. And exponent 0 will always give you a 1. Then we're going to start talking about negative exponents. And then that's where it's going to switch and turn into fractions for us. So this guy here, again, I would divide by my base, divide by 3, divide by 3, divide by 3, and now I get 3 dividing by 3, which is going to give me my 3 to the 0, which is 1. So generically, they're saying anything a exponent 0, anything exponent 0 equals 1, unless you've got some negatives attached to it, etc., etc. Okay, so anything exponent 0 will give you a positive 1. All right, we need to evaluate the following, which means just solve it. And if you're not sure, go to your calculator and type it in, because it's going to tell you if you type it in exactly as you see it with the brackets. It'll show you whether it's a positive or negative answer. Exponent 0 tends to be positive, so watch for your floaters. This guy, there's no negatives. He's got to be a positive 1. There are no negatives. He has to be positive. B, negative base or floater? Negative base. Good, because I have a hidden 1 in there. So if it's a negative base, my answer is going to be positive 1. Okay, it's not going to be a negative 1. It's going to be positive 1. And now you're wondering why. Well, it's exponent 0. Everything disappears and becomes a 1. But why would a floater give me equal to a 1 if it's negative? Why 0? Well, we find out with another pattern that with even numbered exponents, any negative will always give you a positive if they're in brackets. So 0, as we know, is considered an even number. So even number exponents will give us positive answers with negative bases. So if I've got negative 3 to the 4th power, 4 is even, that's going to give me a positive answer. Okay, so anything with an even numbered exponent with a negative base, you get a positive answer. And that's why it's a little bit of a mind trick when you talk about a negative with a 0. The negative with a 0 exponent is still a positive 1 because all of this disappears and becomes a 1. Okay, and again, it's because it's an even exponent on it. Okay, so I have to write where I've got this. The 0 should be on the outside of brackets. My bad here. So it should be on the outside of brackets, because on the inside of brackets, you need to have that hidden positive 1 to make it a negative base. So if we've got those hidden positive 1s to make them negative bases, that's when we apply the even or odd exponent. So if I've got an odd number exponent, let's say I've got negative 5 to the 3, an odd number exponent's going to give me a negative answer. And that's any odd number exponent. So it could be 3, 5, 7, 9, a 1, okay? So if it's just -5, exponent 1, and it's got a hidden 1 right here, so I know it's a negative base. That negative belongs to the 5. So that means it's going to be a negative answer because exponent 1 is odd. 1, 3, 5, 7, 9, it's odd. They're going to be a negative answer. These other ones with even exponents, negative bases, they'll give you an even positive answer. So this guy here, no brackets, that's a floater. Floaters will always make your answers negative if there's only one negative. Okay, so you're going to get a -1 for that guy. Now, the next one's a little bit of a mind trick as well. So you've got a whole bunch of things multiplying in. So when things are sitting side by side, they mean multiplying. So this, if I were to expand it, means 2 times 6 squared all to the 0. Now, 6 squared, what would 6 squared become? If we said and use BEDMAS, we're solving inside the bracket. What would 6 squared become? 36. So this is actually 2 times 36 exponent 0. Well, what's anything exponent 0 if there's no negatives? 1. So now this is going to disappear and become a 1. So we get 2 times 1, which is just 2. So this will give us an answer of just 2. Okay? Any questions with those examples? Okay, we're just reviewing our exponent laws from last year, so hopefully they're starting to ring a bell. All right, exponent laws are on the next page. We will do a couple examples. So it says the exponent laws with whole number exponents and numerical bases are covered in previous math courses. We're going to be getting into the negatives. So this is what we learned in the past. So if we have a number base versus a variable base, do the rules change? No. So if I take a look, if I'm multiplying, I add exponents. Why would I add exponents? Because if you were to write it out and expand it like they did here, this is expanded. The exponent tells you how many of those numbers you have. So if I expand it, I've now got 5 number 8s. Well, if I've got 5 number 8s, my exponent's going to be a 5. That's where this number 5 comes right there, because I've got 5 8s. Now, the short trick, instead of writing it all out, is just to add the exponents. So when the bases are the same and you're multiplying, kick that multiply sign over to a plus, and you are going to add exponents. Okay? So multiply, same base, add exponents. That applies to variables. So multiplying, same base, same letter A's, we're going to add their exponents. So I'm going to get a 3 plus 2, which is going to give me a to the 5. I get a 3 plus 2. So our product law, the product law says if you multiply, same base, you add exponents. So here I'm going to circle those and I'm going to get a m plus n. And that's the generic form of saying add your exponents. Same base, add exponents. Then we're going to do the opposite. So the opposite of multiplying is dividing. So now we get into dividing. If we're dividing, we can show it as a fraction. They can show it left to right like this, or they can show it up and down like this. Either is correct. When you write it up and down, it's easier to cross off the number 8s though, because what is a digit divided by itself give you? If I've got 5 divide 5, what would you get? 1. So if I've got 8 divide 8, I get 1, which means you cancel or cross off. It's called finding or simplifying your ones. So if I say to you, simplify the ones, you're going to look for ones you can cross off. Those are simplifying the digit to a 1. So now this becomes 8 times 1, which is just 8. Okay, does that make sense by simplifying them to ones? where you've got a number on top of itself. It becomes a 1. Yes, we call it canceling, but canceling actually means you're simplifying to a 1. That's what you're actually doing. They don't just cancel and disappear and go away. They become a digit 1. So now over here, we subtract. We would take 3, subtract 2, subtract your exponents. Same thing with the letters. We would cancel the letters to our baby 1s. We would get a times 1, which is just 1a, and we get a exponent 1, 3 subtract 2. So now with our quotient law, you can show it left to right, or you can show it up and down, whichever it is. They both mean the same thing. So the generic form is to say m subtract n. Base A, m subtract n. And they're telling us because it's in a fraction form, the letter A can't be 0. And the reason is you can't divide by 0. And your calculator will tell you that. If you say 4 divide 0 or anything divide 0, it's going to say error. Literally can't divide 0. Okay? Can't divide by 0 is what it'll tell you. Okay, the next one. The only difference between, we're going to call this number 1, number 2, number 3. The only difference between number 1 and number 3 is now you've got 2 different things in the brackets. So instead of 1 digit, I'm going to have 2 different digits. This one's showing an 8 and a 7. So I've got 3 8s and 3 7s. So I have an 8 8 8 and a 7 7 7. So what that's telling me is the inside numbers are both getting the exponent because each inside number has a hidden 1. So what's happening to that 3? It is distributing to those other exponents, which means outside exponent multiplies in. It multiplies to all exponents inside. Inside brackets. Okay, so make sure you write that little note down, that the outside exponent multiplies to all of the inside exponents. So if the 8 had a 2, it would multiply to the 2. And we're going to notice the exact same thing with variables. So the variables have hidden baby 1s on them. The 3 is going to multiply in, and it ends up being A3, B3. We can expand it with 3 A's and 3 B's. So the generic form is A exponent M, B exponent M. They both get the exponent. And the thing is the M is timesing by the 1, and so is the N. Or it's only one letter, I should say, because they each have baby 1s on them. Same thing's going to happen if you have a fraction. So if it's in fraction form, yep. Where am I at? Oh, yep, thank you, man. I appreciate that. It's supposed to be a 3. So glad somebody's paying attention. All right. Moving on to the fraction ones. The same thing's going to happen. This is just telling us we have 3 of the same fraction. 3, 8 over 7, 8 over 7, 8 over 7. So it's telling us the same thing. A over B, A over B, A over B. I have 3 8s, so I'm going to put a 3 on the 8. I have 3 7s. I'm going to put a 3 on the 7s. And again, each of them has a hidden 1. So that 3 is multiplying in the bracket to all the exponents. It's still that same rule. Okay, the outside exponents are multiplying inside. It's the same rule. So same thing on this one. The A is going to get a 3 and the B is going to get a 3. It's both going to get the number 3, not just the top one, both of them. So our generic form, we are going to say A exponent N over B exponent N. They both get the same exponent because they both have hidden 1s, and that N is multiplying to the 1. If we look at the last law on the page, law number 5, this one is just showing you have one base in a bracket. One base with an exponent, you're going to multiply exponent to exponent always. So again, it's that same rule. You're going to multiply any exponents inside by the number outside. So that tells me I have two 8 exponent 3s, which is 8 times 8 times 8. 8 times 8 times 8. How many 8s do I end up with? 6. So I could say 8 3 times 2. So you're multiplying the exponents. Same thing is going to happen to this one. I have two 8 to the 3s. So I've got A times A times A and another group of A times A times A. So I would have A6 or 3 times 2. Two groups of 3. So our generic statement we're going to say is A M times N. Okay, A to the M times N. So if I've got the number 7 to the 4th power, all cubed, you're going to take those two and multiply them. And that's going to remove the brackets. So I'm going to get 7 to the 12th power. So you're noticing on every single one of these steps, on this one, and this one, even including the one before, it didn't have brackets, but anywhere they had brackets, the minute you take the outside exponent inside, it removes brackets. So that's the process to remove the brackets. Okay? So all three processes, this one right there, that one right there, and that one right there, they all remove the brackets. Okay, and that's a key thing to remember. They all remove the brackets. Okay, we've got a couple examples, and then that'll be the end of the lesson. Top of the next page, please. Okay, here's our last 9 examples. So we're going to use the exponent laws to simplify. And then it says evaluate. So if we simplify, we're going to simplify it to a power. Then we're going to solve it with our calculators. So when I multiply, I'm going to add exponents. So that's going to give me 3 exponent 6, which is going to evaluate. We're going to check on our calculators. I'm going to go 3 exponent 6, enter. I get 729. So this guy solves to 729. Now I've got it written in fraction form. When it's written in fraction form, it means dividing. So if I'm dividing, the bases are identical. That means I subtract exponents. So I'm going to take the 5 and 3 and subtract them. So I'm going to get -2 exponent 2. Now there's a hidden 1 on that inside number. There's a hidden 1 here. So that's a negative base. So that's a -2 times a -2. So with an even exponent and a negative base, we know this gives us a positive answer. It's going to be a positive 4. Okay, because it's a negative base and I have an even exponent. Next question, side by side, you're literally multiplying. That's going to remove brackets. So we're taking 2 times 3 to give me 5 exponent 6, and we will evaluate that to 15,625. Whoa, that 6 had an issue. Okay. More simplifying, but now we're going to use coefficients and variables. So we're going to use both now. So if I look at the next one, side by side, whenever brackets are being side by side, it means multiplying. So if I'm multiplying, I'm going to add exponents. So I'm going to add the 4 and the 3. I'm going to get a exponent 7. And again, when you do that, it removes brackets. Don't forget to draw your hiding ones. So I'm going to draw my hiding ones so we don't forget they're there. On my X, my Y, I'm putting all my hiding ones on all my things here. The letter C has one, the S and the T. Put all my hiding ones on there. The 3, the P, and the Q, they all have hiding ones. Okay, I got all my hiding ones on all of the questions. Now we're going to simplify them. So side by side again means multiplying. So we're going to add the exponents. That's going to get, whoopsie, letter X, not A. We're going to get letter X, exponent 7. Okay, let's pay attention back there. We've got B's. We're multiplying, so we're going to add them because it is same base. So I'm going to add 7 and 0 and 4, and I'm going to get B exponent 11. The next one show dividing. Dividing same base means I'm subtracting exponents. So I'm going to get X exponent 4. I am subtracting exponents when I divide. Same situation here. I am dividing, so I subtract exponents, just like I did with letter D. So it's not going to be 10 exponent 5. You're not dividing exponents. You're subtracting them. So it's going to be Y8. So Y exponent 8. The next one, we do see brackets, an exponent inside and outside. So we're going to circle them and multiply them. That removes our brackets. So that's going to give me A exponent 12. Okay, moving on to our bottom row. Again, we've got multiplying happening because we've got brackets and then exponent inside, exponent outside. We're going to multiply them and get 25. So we get Y exponent 25. And again, I drew in the hidden ones. The outside exponent is always multiplying to inside exponents, to all of them. So it's going to give the top numbers and the bottom numbers. So I'm going to have X9 over Y9. The next one, I forgot my 4. The 4 has a hidden baby 1 on it as well. So it's going to get that 2. So he also follows the rules. So I'm going to get C exponent 2 over 4 exponent 2. Now it says evaluate. If it's a digit, I can solve it. So the part I need to solve is 4 squared. So this is actually going to become, come on now, equals C squared over 16. This would be your final answer. You need to solve the digits always. Moving on to letter J. I have an S and a T in brackets. I'm going to multiply the number 6 into the exponents, and that's going to remove brackets. So I'm going to get S exponent 6, T exponent 6. Removed brackets, we are done. There's no digits to solve. However, letter K and letter L have digits we solve. So there's no negatives. I don't have to worry about whether my answer is negative or positive, but I have little baby 1s on the inside. Well, that means my 5, just like my 6 on the last question, it's going to multiply into those 1s. So it's going to become 2 exponent 5, A exponent 5. But now again, I've got digits. So we're going to solve the digit part. So 2 exponent 5, if we solve that, we're going to get 32A exponent 5. If it was multiple choice and they said simplify or evaluate, both of those mean to take it down to 32. You would not leave it as 2 exponent 5. And if it's multiple choice, that answer will be there. So you have to know that it wants you to solve it completely. Last question. This one has a negative. So this one we have to realize that it's going to apply to that 3. It's a negative base. It's a negative base because the 3 has a 1 on it. So that means there's 4 negatives. If I have 4 negatives, it's an even number of negatives. My answer is going to be positive. So I don't even have to worry about all the negatives. I know my answer is positive. Now I just deal with multiplying the exponent inside. So that outside exponent, that 4, is going to be given to the 3, the P, and the Q. So my negative is gone. I get 3 exponent 4, P exponent 4, Q exponent 4. And now again, I've got digits that I need to solve. So I'm going to use my handy dandy calculator, and I'm going to put in 3 exponent 4 and get an 81. So my final answer is 81 P4 Q4. And that concludes lesson 8, powers and whole number exponents.